Professor Leo here, and as usual, I've got my trusty porta-piper.
Call me porta-piper one more time, and I'll zap you.
Empty threats, porta-piper. Whoa. Today we're on location at a real-life drilling rig, just like what the dentist uses on your mouth, only smaller. Let's take a closer look, shall we? A drilling rig is used to drill a hole in the ground to reach the oil and natural gas underneath. As an added bonus, it looks like a commemorative Eiffel Tower. There are so many moving parts and pieces of heavy equipment inside a drilling rig that someone without training should never go near it. These professionals go through hours and hours of safety training just to work on a rig. Heck, the trained professionals told me themselves that I can't come near the rig without wearing a hard hat, goggles, flame-resistant clothing, steel-toed boots, gloves, a feather boa, and rabbit ears. Though those last two might have been a prank.
You think?
Safety doesn't just apply to workers on the rig. It's incredibly important to protect nearby communities and the environment as well, especially all of our freshwater formations underground. This is accomplished with what we call the surface casing, which is basically a large diameter solid steel pipe.
Very good, Professor Leo.
I read it on the card. The rig first drills a hole to a depth well below the freshwater table. The surface casing is then cemented in place to seal off the fresh water from the wellbore, or drill hole.
An extra measure of protection.
Ah, like when my mom made me wear 2 diapers on those really thirsty days. Once the surface casing is cemented in place, the rig workers continue drilling. They use a smaller diameter pipe that fits inside the surface casing.
Let's take a look at the pipes. When you put these pipes together, they're called a drill string. The crew will connect the pipe to a drill bit.
That's that gnarly looking dude right there. It's used to crush the rock, breaking it up into smaller pieces. Metal drill bits can be as small as 2 inches or more than 3 feet wide. The crew will continue adding more and more pipe, which allows the bit to keep drilling deeper and deeper.
Though some wells have been drilled to deeper than 30,000 feet, the average well is 7,700 feet. To help put that in perspective, that's longer than 25 football fields lined up goalpost to goalpost.
It's also longer than 7,700 footballs! Huh? But let's go with yours. Yep, yours is better.
Now the pipe and drill bit are connected to a top drive, which turns them to crush through the rock.
Top drive! Sounds like a reality competition featuring talking cars. Top drive!
The top drive, in turn, is powered by the engine.
Top drive. It's like an electric drill, pushing through material. That's how the pipe and drill bit work too. Only on a rig, it happens on a much larger scale. So what keeps this all in place? That would be the derrick.
Not that derrick.
Hey, Derek! What's up, bro?
This derrick.
Oh. The metal frame supports the drill string and drill bit. Remember them? The derrick needs to be very tall because as drilling progresses, there has to be enough room for the next section of drill pipe to be added. The derrick's height helps make the drill pipe's trip quicker in and out of the well. And here we have the crown.
You finished?
You're no fun.
The crown, of course, is at the top of the rig and is used to support the raising and lowering of the pipe.
It also gives the derrick an annoying superiority complex. But that's neither here nor there. Now let's talk about my favorite part, the drilling mud. Like me, you probably thought mud was only for eating, moshing, and hurling at toddlers. But that's where you'd be wrong. On a rig, drilling mud is actually a combination of several different fluids. The mud flows down through the drill string, out the drill bit, and back up the hole. Pretty awesome, right? Mud fight!
The mud also brings rock cuttings back to the surface to keep them from filling up the wellbore.
Once they're on the surface, the rock cuttings are examined to see if they contain hydrocarbons. That is a shell shaker! It's used to remove solids from the mud! The wire screen vibrates while the drilling fluid flows on top of it. The mud passes through and is reused.
Anything bigger stays on the screen.
Now, you may have thought drilling only went straight down into the ground. Most people do. It's not a super big deal. Only Kind of embarrassing, I guess, when you think about it. Maybe don't mention it in public. For a long time, you would have been correct, but thanks to the high-octane brains working in oil and natural gas, we now have an advanced process called horizontal drilling, which means drilling horizontally.
With horizontal drilling, we're able to reach oil and natural gas in places we never could have reached before. And we can do so while drilling fewer wells.
Once we reach what's called the kickoff point, we then place special tools in the drill string. These special tools communicate with computers and people on the surface and allow us to control the angle and direction of the drill bit. Then we begin horizontal drilling. After that, we cement the casing into place, and then we perforate. Perforate, to create holes for fluids to flow into and out of the casing.
You don't understand anything you just said.
Not one word. But I do know that there's still several more steps left before the oil and natural gas finds its way to the surface. But that's a field trip for another day. Say goodbye, Porta Piper. Yeah.
Goodbye.
My name is Professor Leo, and this has been a pre-recorded video.